Next, we're going to talk about the complement of a set. The complement of a set, symbolized by a prime, that's like a little apostrophe up there, is the set of all elements in the universal set that are not in A. So A prime, or the complement of A, is equal to the set of all x, such that x is in the universal set and x is not in A. So remember, the universal set is always the set of everything that's even possible in the conversation. So, for example, if we say let U equal A, B, C, D, and E, the set, and A is the set of A and D, find A complement. So what I'm going to do is I'm going to have a box over here, and that represents U. Then I'm going to put a circle inside, and we're going to call that A. And the elements that belong in set A would be the lowercase a and the lowercase d. Now, all of the elements of U, A, B, C, D, and E, all have to belong in our picture. So they either have to be in A or not in A. So A is in A, B is not, so we're going to end up out here. C is not, so it's going to end up out here. And D is in A, and then E is not, so that also ends up out here. So A is all of the elements that belong inside the green space, okay? And then the A prime would be all the elements that don't belong, so all of the stuff out here. Okay? Alright, so when I'm talking about A prime, I'm asking what belongs in A prime, which is the complement of A, that it does not belong in A, but it belongs in the universal set. That would be B, C, and E. The complement of A is the elements of B, C, and E. So the union of sets, if I take set A and set B and I'm taking the union of that, we write that A union B like this, is the set of all elements that are members of set A or of set B or of both. Okay, so as long as they're in A or B or both, that's the union. The intersection of sets A and B, written A intersect B, is the set of all elements common to both A and B. So they have to belong to both A and B. So just in words, this would be both A and B. And in words, union would be more like either A or B. Union is a whole lot more accepting. Intersection is much more inclusive. It has to be both A and B in order for it to work. So we're going to talk about how to do some of these set operations. So let's say I have the set of 1, 3, 5, 7, and 10. And I'm taking the union of 6, 7, 10, and 11. Union means that as long as an element belongs to either of the sets, it gets to be included in the union set. So I get to include everything in the first set, 1, 3, 5, 7, and 10, and everything in the other set, because it can be either. Okay, 6, 7 I'm not going to write again because it's already there. 10 I'm not going to write again because it's already there. And then 11, and that is the union of sets. Now let me take that same two sets, and I want to do the intersection. So the intersection means it has to belong in both sets. What do you see common in both sets? Well, I see a 7 common in both, and I see a 10 common in both. So in this case, the intersection, which is more inclusive, is just 7 and 10. Next one, the set of A, B, C, union the set of D, E, F, and G. So in that case, I'm taking every element that's in the first set. Union mean including either, as long as it's in either one of the sets, it belongs in my answer set. Every single thing. Now there's nothing that overlapped at all, and so I just get to write the whole list out. The next one, what is the intersection of the set of A, B, C intersect with the set of D, E, F, G? What do you see that's common in both A and B? Well, there's nothing. So you would just write the empty set. There's nothing that would belong in there. Another way of writing the empty set is a circle with a slash through it. I kind of like the empty set better because I can totally see that, hello, there's a set there, but there's nothing in it. Let's do some more examples here. We have a universal set, 1 through 7, whole natural numbers. And then we have sets A, B, and C here that include some of the universal set. So let's see. If I have A intersect B, so we're talking about all of the items that are in both A and B. Intersect means it has to have some of both. So it looks like 1 is included in both, and 3 is included in both, and I think that's it. So for the A intersect B, I've got 1 and 3, the set of 1 and 3. How about B union C? If I'm talking about union, that means anything in B and anything in C. So I'm going to start with all of the elements of B, and then just start listing all the elements in C as well that aren't copied. So 2 is already there, so I don't need that. 3 is already in there, okay. 4, 5, and 6. So the union includes everybody in B and everybody in C. How about A intersect with the empty set? This is the empty set here. So what belongs in A that is also in the empty set? Well, there's the empty set. If you want to think about that over here, let me add it. What belongs in A? What elements are in A and also in the empty set? Well, there isn't any. So either the empty set, or you can write it that way as well. When I'm talking about A union the empty set, I'm talking about all of the elements in A, in addition to all the elements in the empty set. Well, there isn't anything in the empty set, so it's just basically the elements of A. So what this means is when you have any set P and you intersect with the empty set, you're going to get the empty set, or written that way. But if I have any set P union with the empty set, it's always going to be the set P. For any set there is. If you ever union it with the empty set, it's going to be itself. If you ever intersect it with the empty set, it will be the empty set.